Alright, this is Station 6. It says find the ratio shaded to unshaded of the areas. So once it gives us shaded to unshaded, that means we have to use that order in terms of ratios. So, which means I have my two figures here, 1 and 2. The thing that I noticed, they're two triangles. We have to have a corresponding side length in order to compare the different lengths. So we have one that's opposite the 90 degrees, but here we have actually opposite the 30 degrees is the missing one. So we need something opposite the 90 degrees. If you remember in a previous chapter about 30, 60, 90 triangles, the ratio, if you're going from opposite the 30 to opposite the 90, you just multiply by 2, which would give you 16. If you didn't know that and you were trying to find out what x was, you could technically use opposite and hypotenuse. Opposite and hypotenuse was SOHCAHTOA. So sine of 30 equals opposite over hypotenuse. If you cross multiplied and solved, you would get x equals 16. It would be the exact same. So if you understand the 30, 60, 90 triangle, awesome. If you don't, use the trig, and that's completely fine as well. So once I know that, my corresponding side of shaded to unshaded would be 18 is to 16. But since these are areas, you have to make sure that you square that. What I'm going to do, just because, is reduce this first, just because it's going to make it a little bit easier on my end, which would be 9 to 8. Then I square it, which gives me the area of the shaded region 81 to the area of the unshaded region 64, and that's it. You're done. For the next one, this is much easier because we can automatically see what a corresponding side length is. We don't have to do any figuring out. I can just do 10 is to 15. Again, it's easier if you reduce it first, so 2 to 3, and then square it. So square it, which gives you 4 is to 9. And you're done. That's the area of the shaded to the unshaded. And you cannot reduce this anymore. Finished.